So when we think of any flat two-dimensional surface, we really, in the math world, want to have some way to kind of map where one thing is relative to another. So that's this idea of the rectangular coordinate system and just dealing with graphing in general. So when we're talking about graphs of functions and just really representing many different things, a map of like cities or states, we need to have some starting point and we want to know a distance from that starting point. So here we're going to go over all of the different vocab for our rectangular coordinate system. So we're going to start, we have these two different axes, one of them going horizontally and one of them going vertically. So these are called our x and y axes. The x-axis is going to be the one that's going across. So x is across. The y-axis is to the sky. So x across, y to the sky. Where these two meet is going to be a very specific point. This is called our origin. So everything originates from there. So when we're working with problems, we always want to give some kind of scale. This origin is going to mean that I'm moving nothing in the x or y direction. Now, if you think of just generally positive directions, up is considered positive. So if I move up along the y-axis, giving these a scale of 1 would be 1, 2, 3, 4. Then for the horizontal, right will be considered the positive direction. So again, just going to count up by ones, but it could be problem specific that you need to do something else. So 1, 2, 3 in this direction. The other two, if I move left or down, are going to consider negative values. So this would be -1, -2, -3, -4, and then going down, same thing. So your scale may be different just based on your problem. What this does is it actually splits our two-dimensional flat surface into what we call quadrants. So there's one quadrant here, another quadrant here, here, and here. These arrows on the end are indicating that you're moving forever in each direction. So this goes on forever to cover the entire flat surface. Now in math, you're really used to working clockwise, but math is going to be the opposite. So our first quadrant is going to be the one where both moving is considered positive. So to the right in the x and up in the y direction. So that is quadrant 1. We use Roman numerals. Now typically you'd think you would go 2, 3, 4 in this direction, but again, we go counterclockwise. So quadrant 2 is actually going to be over here. And instead of writing quadrant out, you can just say Q2. This one would be quadrant 3, which in Roman numerals is 3 I's, and then quadrant 4, 4 in Roman numerals is IV. So every single point that you're going to plot in this two-dimensional rectangular coordinate system is called a coordinate pair. The order does matter. The very first number indicates how far you move in the x direction. The second number indicates how far you move in the y. If it's positive, that means you move positive in the x direction. If it's negative in y, you move negative in the y. So every single point that you plot is going to have an x coordinate followed by a y coordinate. The reason this is called the rectangular coordinate system is because if you drop a straight line down and to the left, it creates a rectangle with the origin. So let's try to get some practice just plotting some points. And after we plot them, we're going to name the quadrant or axis where that point ends up lying. So before I even start, I need to go ahead and label everything. I'm going to start just by labeling my quadrants. This is quadrant 1, quadrant 2, quadrant 3, and finally quadrant 4. This is my x-axis, and this is my y-axis. Looking at all of the points I have to plot, I don't have any ridiculously big numbers like 1,000 or a couple hundred. So that tells me each of these lines I can really just count as one. So where these two both meet is 0, and actually going back up here, the origin means you don't move in the x or y, so that has coordinates 0, 0. Now if I move right, that's considered positive, so I'll count up by ones. Up is positive, and then left and down are negative. So -1, -2, -3, -4, -5, -6, -1, -2, -3, -4, -5, -6. So starting with point A, I want to go -4 in the x direction, -2 in the y. So starting at that origin, I'm going -4 in the x direction, and then -2 in the y. So point A would end up down here. And I'm going to get rid of these because point A is, again, just a point. And so if we try to figure out where this ends up, it lands in quadrant 3. Moving on to point B, we move 5 in the x direction, 5 in the y direction, and they're both positive. So again, I'm going to go over to 5 in the x, 5 in the y, and so the 0.55 would be right up here. So this is where B is going to lie. And then if we consider that quadrant, that lands in quadrant 1. Moving on to point C, my x coordinate is 0, but my y coordinate is 2. So that means starting here, I do not move in the x direction, but in the y direction, I move up to +2. So point C is going to land right here. Okay? So I have not moved in x, only in the y. So if I'm considering which quadrant this is, it's not in a quadrant, it's on one of my axes. So this lands directly on the y-axis. Okay. Moving on to point D, I go +3 in the x direction, -3 in the y. So that means we move down, and that would land me right here. So again, if I were to draw straight lines to each of these, you would see my x is 3, and then my y is -3. So point D is going to be this point over here. And the quadrant it lands in is quadrant 4. Okay. Finally, for point E, you move -3 in the x. We do not move in the y direction at all because it is 0. So point E lands right here. So if I'm considering which quadrant it is, it's not in, it's on one of the axes, and this lands exactly on the x-axis. Okay. So now let's try some applications of this. We're given a graph, and we're given a bunch of different cities. We want to write the location of each city as an ordered pair. And again, the order does matter. It's x, then y. So starting with our first point, Seattle, if I locate that on my graph, what I want to do is I want to start by writing my x coordinate. So I'm going to go ahead and just draw a straight line down to see my x coordinate is at -8. To figure out my y coordinate, I'm going to draw a straight line to the y-axis, and that lands in between 8 and 10. So my y coordinate is +9. So Seattle as an ordered pair would be -8, +9. Moving on to Denver, which is this point right here, I do the same thing. I got to start with the x-coordinate. So I'm going to draw a straight line to the x-axis to see that x-coordinate is -6, and a straight line to the y-axis to see the y-coordinate is +4. Moving on to Boston, which is over here, seeing my x-coordinate is +8, and my y-coordinate would be +7. Okay. Then Phoenix is over here in quadrant 3. So dropping a line to the x-axis, that falls in between -6 and -8. So my x-coordinate is -7. And my y-coordinate, drawing a straight line over, would be -9. Then we've got Dallas here in quadrant 4. So again, draw a straight line to the x-axis. That's at 3. A straight line to the y-axis for the y-coordinate. That is -5. And then last but not least, we've got Atlanta. The x-coordinate would be +6. And the y-coordinate will be -8. And so this is a nice short section. We really just have one last example. So we're going to use the graph to determine the behavior of the function between the indicated points. So what we're really trying to figure out is from point A to B, is it increasing, decreasing, or constant? And then the same thing for all the other points. So just like you read an equation, just like you read a sentence, you do everything from left to right. So starting with this first piece, I want to go from A to B. So if I think about how I'm traveling along this graph from A to B, I'm going down. And if you think of down, that would mean that the graph or the function is decreasing between these 2 points because it's falling. Moving from B to C, if I go ahead and trace that graph here, my graph is climbing upwards. So we say the graph is increasing on this portion. And then moving from C to D, if I trace the graph between those from left to right, it's falling. So again, this is decreasing on this interval. And then last but not least, from D to E, if you notice absolutely nothing is happening, you are staying constant between these points because it is level. Okay. So the vocab means exactly what it does in our normal English in terms of our graph.